This is a Landsat image of part of the Arctic ice pack. There are ice floes of various sizes, the solid bright areas, broken ice, the gray areas, and open water, the black areas. We would like to develop a method that can be used to automatically identify the ice floes. When we look at the image, the ice floes that we easily see are those that are in sharp contrast with their background, those that have water around them. The floes that are in the broken ice are not so readily discernible. If we add color to this grayscale image, the floes are much easier to see. This is because the particular color map we are using has increased the perceived contrast between the floes and their background. Since the ice floes are composed of high-intensity pixels, we can increase this contrast further by setting all the pixels below some threshold level to be black. You may notice that some of the floes now seem to be more distinct. This is because there is a program currently running which is doing just that. It is slowly increasing the threshold, which causes more of the low-intensity pixels to turn black. The result is the apparent highlighting of the floes. As can be seen, this thresholding process can be carried too far. This is an enlarged section of the previous image with a threshold level that has removed much of the clutter around the floes, but has not seriously degraded the interior of the floes. We want to identify the individual floes. To do this, we will find the edges. We will define the edge of a flow to be all the pixels on the border of that flow. That is, all the pixels that are part of a flow and have a black neighbor. Since the computer doesn't know which of the non-black pixels are part of a flow and which are broken ice that was not eliminated by the thresholding, we have to consider all non-black pixels which have black neighbors. Here are those pixels highlighted in white. Keep in mind, currently the computer just knows the locations of these white edge pixels. It has no way of knowing which of them go together to form the outline of a flow. In order to group those edge pixels which belong to a common flow and, at the same time, eliminate the noise, broken ice, and flows too small to be of interest, we will simulate melting the ice. The location of the edge pixels will be passed into the flow as the ice melts. The last piece of ice to melt from each flow will then know the locations of all the edge pixels for that flow. The white pixels will be the first layer to melt, but we will leave them in the image to show the outlines of the flows. As the rest of the ice melts, it will turn black. Notice how some of the larger flows have edge pixels in their interior. These are from melt ponds on the flows. As the melting progresses, these melt ponds will leave us with edge pixels inside the flows. This will be taken care of the next step by using a smooth curve estimate to estimate the outline of the flows. Here is the edge pixels after eliminating the small flows and broken ice. Here are the edge elements of one of the flows. The points inside the flow are from a melt pond. We want to represent this set of points with a smoothed curve. We will use what's called a principal curve. It was developed by Trevor Hasty. Finding a principal curve is an iterative procedure. We will project these edge points onto estimates of the curve and then adjust the estimates based on the projections. We initialize the procedure by projecting the points onto this circle. Some of the points are inside the curve and some are outside. This is an important distinction when estimating the curve. The lines are the projections of the points onto the circle. The red lines indicate the point is interior to the flow. The blue lines are for exterior points. This color coding is useful in making sure that the program is calculating the interior and exterior points correctly. Notice that the points from the milk pond are projecting onto the circle. That is because we are using all the points to calculate the next estimate of the curve. We don't want points which are not on the border of the flow to have an effect on the estimation of the principal curve. The program will determine which points should not enter into the estimation procedure. Those points will be colored green, and no projection lines will be plotted. The program is now estimating the principal curve. We can actually watch the algorithm proceed. Notice how the points inside the flow, those from the milk pond, are not entering into the estimation. There are no projection lines for them. This is the final curve representing the outline of this flow. These are the outlines of the flows with the principal curves added to them. Here is the original image, and here are the principal curve outlines of the flows.